Okay, so let's unpack this. Imagine pointing a telescope, right, at a familiar patch of our own galaxy, the Milky Way, a place you think we kind of know pretty well, and then bang, you find something totally unexpected, something that looks, well, almost too perfect, based on everything we understand about how space stuff, especially explosions, usually works.
Yeah, it's exactly the kind of thing that makes astronomers just stop
Hmm.
and scratch their heads a bit, make some questions, some really basic ideas, like finding a perfect circle drawn neatly in the middle of cosmic wreckage. It just doesn't really fit the picture we have.
Exactly. And that's the puzzle we're diving into today. We're looking at this really fascinating report about a new discovery. It came from the Australian SKA Pathfinder telescope. Maybe you know it as ASCAP. And this find is genuinely, well, shaking things up a bit in astronomy.
It's a proper cosmic mystery. And
Yeah.
not, light years away in some super distant galaxy. It's right here, in our neighborhood.
Yep. So the object we're talking about, its official name is G305.422.2. Bit of a mouthful, but it's already got this much cooler nickname, Teleos.
Teleos, yeah. It's from ancient Greek. It means something like perfection or completeness.
And you'll definitely see why that name fits as we get into the details here.
Absolutely.
So our mission today, figure out what Teleos actually is. Explore why its shape, this incredibly perfect circle, is so strange, so unprecedented compared to everything else we've seen. And then dig into the big questions scientists are grappling with because of it. And, look ahead to what might help solve this cosmic riddle. We've got this report, and we're just going to pull out the absolute key stuff about this mysterious perfect circle.
Right, let's get into it. So the discovery, like you said, came from ASCAP in Australia. And ASCAP is great because it's designed to scan huge chunks of the sky really efficiently using radio waves.
And when it looked at this particular spot in the Milky Way, it found Teleos. The report describes it as basically a giant bubble of plasma.
Huge, yeah. But here's where it starts getting really weird.
Yep.
Okay, so it stands out clear as day in the radio spectrum. Big signal. But when astronomers pointed other telescopes at it, ones that see visible light or infrared or even X-rays,
They found
nothing, absolutely nothing. It's like it's completely invisible across almost the entire way we usually look at the universe.
Wow. So a massive bubble of hot, energetic plasma that you can only see with a radio telescope. That's already pretty odd, wouldn't you say?
Definitely odd. But the real head scratcher, the reason it gets that name, Teleos, is its shape.
Right, the perfection part.
Exactly. To really get why this is so baffling, you need to picture what happens after a typical massive star explodes, a supernova. A star way bigger than our sun goes, boom, blasts all this stuff out into space, energy, material, everything.
And that leaves behind some kind of structure, a remnant.
Precisely. Usually these remnants are shells of gas and dust, still expanding outwards from the explosion. But here's the key thing. Space isn't empty. It's not perfectly smooth either. There are clouds of gas floating around, clumps of dust, magnetic fields. It's kind of a messy, turbulent place.
Okay, so the explosion wave, the shock wave, smashes into all that mess.
Right. It hits denser patches, gets slowed down here, maybe deflected over there. Plus, the original explosion itself might not have been perfectly symmetrical to begin with, so the result, the supernova remnant we actually see later on, tends to look, well, the report uses a great phrase, Frizzy shells.
Frizzy shells. I like that. Sounds chaotic.
It is. They're irregular, lumpy, stretched out, definitely not symmetrical. Think about like blowing a bubble underwater versus in the air. The environment it expands into makes a huge difference.
Okay, frizzy shells. Makes sense for a huge explosion in a messy environment. Now, contrast that with Teleos.
This is the kicker. The report is really specific here. Teleos is measured to be more than 95% round.
95%.
More than 95%. According to the scientists studying it, this almost perfect symmetry makes it the very first perfect radio circle ever found inside our own galaxy. We see things that are sort of circular sometimes, sure, but nothing this precise, this Teleos.
Wow. Over 95% round, just floating out there in the messy chaos of interstellar space. That's just wild to picture. Like someone dropped a giant, perfect cosmic soap bubble out there.
It really makes you ask, how can that level of violence, a supernova, end up creating something so incredibly neat and ordered? It just doesn't line up with our usual models for these remnants.
And as if the shape wasn't mysterious enough, the report also mentions that actually studying Teleos is tough because it's very faint. It's not exactly shouting its secrets across space.
Yeah, that faintness definitely adds to the problems. It contributes to these huge uncertainties that the report details. Like, for instance, one of the most basic things you want to know is how far away something is, right?
Sure, fundamental.
But for Teleos, scientists just can't agree. The estimates are all over the place. It could be relatively close, maybe 2,200 light years away, or it could be much, much further, like 7,700 light years away.
Hold on, 2,200 versus 7,700, that's more than 3 times the distance?
Exactly, a huge range.
And if you don't know the distance for sure, you can't know the actual size either, can you?
You got it. The size depends directly on that distance estimate. So if it's closer, at 2,200 light years, its diameter would be about 14 light years across.
Okay, 14 light years. Still big.
Big, yeah. But if it's further away, at 7,700 light years, then its diameter balloons out to a massive 47 light years across.
47. Wow, okay, 14 versus 47 light years. That's not a small difference. That's like the difference between, I don't know, a decent-sized nebula and something absolutely enormous, potentially spanning multiple star systems. That must completely change how you think about what could have created it, right? The energy involved?
Oh, absolutely. A much bigger size at a much greater distance means the event that created it had to be way, way more powerful. The sheer energy needed to inflate a plasma bubble 47 light years wide would be vastly different from one only 14 light years wide. So this one uncertainty, the distance immediately splits the possibilities for the power source into 2 really different camps.
And it doesn't stop there. The report talks about age uncertainty, too, another massive variable.
Yes, and it's just as puzzling, frankly. Based on different ways of looking at it, the report gives 2 possible age ranges that are, well, incredibly far apart. Scenario 1.
Yeah.
Could be pretty young. A supernova afterglow that's less than 1,000 years old.
Less than 1,000 years, okay.
Scenario 2, it could be much, much older. Maybe over 10,000 years old.
Okay, hang on. So it's either younger than, say, the Norman conquest of England, or it's older than the invention of farming. Those are just vastly different timescales.
Worlds apart, absolutely. And the implications of that age gap are huge. Think about it. If it's young, less than 1,000 years old, the original explosion should have been visible from Earth. Supernovae in our galaxy, if they're that close and recent, are bright, often naked-eye bright, sometimes even visible in daylight.
Right. People would have seen it, recorded it.
You'd think so.
Yeah.
So if it really is young, the fact that there's no historical record of anyone seeing a bright new star, a supernova, in that part of the sky, well, that's another puzzle piece that just doesn't fit.
Okay. What about the older possibility?
Well, if it's over 10,000 years old, then the explosion happened long before anyone was keeping detailed astronomical records like that. So the lack of historical data isn't a problem anymore.
But then
you have to explain how such a perfect, delicate sphere could survive for over 10,000 years, drifting through the interstellar medium, all that gas and dust and magnetic fields without getting distorted or, frizzy.
Right. How does it stay perfect for so long?
Exactly. So these uncertainties, distance, size, age, they're not just numbers we don't know. They mean we can't even nail down the basic kind of event that created it or how it's changed over time. It's like a mystery wrapped in another mystery.
It really is. Multi-layered.
Which brings us nicely to the next thing the report talks about, possible explanations. And crucially, why none of the current ideas seem to fully work for Teleos.
Okay, so what's floated as maybe one of the most likely hypotheses mentioned in the source? What's the leading idea?
Well, one of the main ideas they explore is that Teleos is the leftover, the after effect, of a specific kind of explosion called a Type Ia supernova.
Type Ia. Can you give us a quick refresher on what that is?
Sure. So, unlike the supernovae from massive stars dying that we talked about earlier, the core collapse ones,
Right.
a Type Ia usually happens in a binary system, 2 stars orbiting each other. One of them is a white dwarf.
The leftover core of a dead sun-like star. Dense. Hot.
Exactly. And if this white dwarf is close enough to its partner star, it can start pulling material off it. Gas, mostly hydrogen. If it pulls enough material onto itself, the white dwarf gets heavier and heavier until it hits a critical limit, the Chandrasekhar limit. When it crosses that mass threshold, boom, runaway nuclear fusion ignites throughout the white dwarf, and it explodes completely.
And these are important because they're like standard candles, right? Consistent brightness.
That's the key thing, yeah. They're remarkably consistent, which lets astronomers use them to measure cosmic distances. Very important tool.
Okay, got it. So the theory is maybe one of those explosions made Teleos, and because Type Ia supernovae might be more uniform, maybe more symmetrical than the big, messy core collapse ones,
So,
perhaps that explains the perfect shape.
that's basically the logic, yes. The thinking is, if you had an especially symmetrical Type Ia explosion, And crucially, if it happened in a part of space that was unusually empty and uniform, hardly any gas or dust clouds to mess things up, then maybe, just maybe, the expanding shell of plasma could keep that near-perfect spherical shape as it grew.
Okay, that sounds plausible, at least on the surface. A very neat explosion in a very neat environment could potentially make a very neat bubble. But you said there are problems. The report immediately points out challenges to this specific idea.
It definitely does, and these challenges are pretty significant. That's why scientists are nowhere near saying, yep, it's a type Ia remnant. The first big issue highlighted is the lack of X-rays coming from Teleos. The report says, quite clearly, it does not emit X-rays, which it should if it were really a supernova after effect.
Why should it emit X-rays? What's the connection there?
Well, the shock waves ripping outwards from these explosions heat up the gas and plasma inside the remnant to incredibly high temperatures. We're talking millions of degrees Celsius. And matter that hot, it should glow very brightly in X-rays. It's a characteristic signature.
So the fact that we don't see those X-rays from Teleos...
It's a major red flag.
Yeah.
It strongly argues against it being a standard supernova remnant, even a type Ia1. That expected heat signature just isn't there.
Okay, problem 1. Missing X-rays. What's next?
Problem 2. The missing core object. Many stellar explosions, especially the core collapse ones, but also potentially some type ES scenarios, depending on exactly how they start, leave behind a dense stellar corpse at the center, usually a neutron star or maybe even a black hole.
The crushed remains of the star's core.
Right. So astronomers look very carefully at the very center of Teleos, searching for any sign of such a compact object. And the report says they found nothing of the sort.
Huh. So no central engine, no tiny, dense remnant left over from whatever supposedly blew up.
Seems not. Another expected piece of the puzzle is just missing.
Okay. And then you mentioned the age thing again, tied to the historical record.
Yeah, that comes back into play here too, specifically for the young scenario.
The idea that if it's less than 1,000 years old, someone should have seen the explosion?
Exactly that. If Teleos is a young type Ia remnant, say 800 years old, the initial explosion should have been visible from Earth. Maybe not super bright, but likely noticeable. But, as the report confirms, there is no historical record of a supernova in this part of the sky. Has there? Now, okay, maybe it was unusually faint, maybe it was hidden behind dust, but for a type Ia, which are generally quite luminous, this lack of any historical mention is, well, it's awkward for the young remnant idea.
Okay, so let me recap the problems with the leading theory, the type Ia supernova idea. Problem 1, it should be giving off X-rays because it's hot, but it isn't. Problem 2, there should maybe be a dense object like a neutron star at the center, but there isn't. Problem 3, if it's young, we probably should have seen the explosion historically, but we didn't.
That sums it up pretty well. Those are major discrepancies. And that's why the report is so careful, so measured in its conclusion about the origin. It states very clearly that basically all the scenarios examine present challenges, and no definitive type of supernova origin can be established at this stage. End quote. They've looked at different possibilities, different types of supernovae, different environments, but Teleos just doesn't neatly tick the boxes for any of them with the data we have now. It really is still a genuine puzzle.
You know, it's moments like this in science that are both, well, frustrating, but also incredibly exciting, right? Hitting a wall like this just means our current understanding isn't the full picture. There's something new going on.
Absolutely. It pushes the boundaries. So what's the next step? How do scientists plan to try and crack the case of Teleos?
Well, the report looks towards the future of radio astronomy itself. Specifically, it mentions the new Square Kilometer Array Radio Telescope, the SKA. It's being built right now, partly in Australia, partly in South Africa.
Ah, the SKA, the next generation powerhouse.
Exactly. The SKA is designed to be way, way more sensitive than current telescopes like ASCAP. And it'll have much sharper vision, much higher resolution.
So it can pick up fainter signals and see much finer details in things.
That's the idea. And how could that help with Teleos?
Well, the hope is pretty straightforward. With the SKA's extra power, scientists should be able to see more clearly into Teleos, as the report puts it. Maybe they'll detect that faint X-ray glow that ASCAP couldn't pick up. Or maybe they'll finally spot a tiny, faint signal from that missing central object. Or perhaps they'll confirm definitively that those things really aren't there, even with much greater sensitivity.
And maybe get a much better look at the structure of the shell itself, see if it's really perfectly smooth or if there are subtle features.
Exactly. Studying the fine details of the plasma, the magnetic fields within it, that could offer clues about how it formed and managed to expand so symmetrically or stay symmetrical for so long.
So the solution might come not just from better theories, but literally from better eyes on the sky, sharper vision.
That's often how breakthroughs happen, isn't it? New technology opens up a new window, lets us see things we couldn't before,
Mm.
and sometimes, like maybe with Teleos, what we see doesn't confirm our old ideas, but instead reveals something totally new, something that forces us to rethink.
This whole story is just, it's such a perfect example of how the universe keeps throwing curveballs at us. You find this object that's incredibly, strikingly perfect in its shape, but perfect in a way that completely messes with our expectations for how things get made in space, especially through violence like a supernova. It's not one of those messy, frizzy shells. It's this beautiful, baffling, perfect radio circle.
It really is a powerful reminder, isn't it, that even right here, in our own galaxy, a place we think we know reasonably well, there are still big mysteries hiding. Our maps, our understanding, they're definitely far from complete.
Yeah. And discoveries like Teleos, they aren't just, adding another weird object to the catalog. They actually push us. They show us the limits of what we know right now. They challenge the models we rely on. And that's what opens up completely new avenues for scientists to explore. It really highlights that exciting edge where the known bumps up against the great unknown.
And it absolutely makes you wonder,
Yeah.
what else is out there? Hiding in plain sight, maybe?
Yeah,
Shaped in ways we just can't explain yet.
it really does. So thinking about Teleos, this perfect cosmic oddity that defies easy answers, here's something for you listening to mull over. What other unknown things, maybe equally strange, maybe just as perfectly formed in unexpected ways, might be lurking out there in the dark, just waiting for a new generation of instruments, like the SKA, to finally bring them into focus?
The universe definitely seems to enjoy keeping a few secrets up its sleeve.
It certainly does. Well, if you found this deep dive into the mystery of the perfect radio circle Teleos as fascinating as we did, and if you want to keep exploring these kinds of cosmic puzzles with us, make sure you subscribe to the deep dive. Wherever you get your podcasts is fine. That way you won't miss our future explorations into surprising science and baffling finds. And hey, we'd actually love to hear your thoughts. Based on everything you've heard today, what do you think Teleos could possibly be? Let us know. Share your theories.
Yeah, definitely curious to hear ideas. Until next time.
Keep exploring the deepa.